Okay, here we have a good core 1 problem about derivatives and applications. So we can't use a calculator or anything fancy. We're just going to have to use our minds. So the first part here, A1, we want to take this function and we want to derive it. So if we have that x is equal to 1/2 t to the fourth minus 20t squared plus 66t. Usually we have, and you may even see dy dx. Well, instead of y, we have x, so that x is in the right spot. dx. We don't have an x on this side, we have a t. So this is actually the same thing. We're deriving the function x with respect to t. Of course, if you weren't confused by that, it's just business as normal. So the power rule, this is going to drop down. So 4 times 1/2 is 2. T to the third, because we subtract 1 from the index there, minus 40t plus 66. This t goes away because it's t to the first, so we multiply 66 by 1. 1 minus 1 for the index is 0, so we get 66t to the 0. So that is right there, and that lovely answer that we just got is worth 3 marks. Perfect. Now we want to derive that again. So, whoops, this is actually dx dt. That is not good. So the mark scheme itself has dx dt. So that's actually a good question. If I had just left this at x in my haste, I probably would have lost a mark, at least one. So be mindful of that. We didn't solve for x, we solved for dx dt, so that's what this equals. So right off the bat, for the next part, I'm not going to play any games here. I'm actually going to put in the correct notation for the second derivative. And again, we're just deriving again, so 3 times 2 is 6, so it's 6t squared minus 40, because now this t goes away, and the constant goes to 0. And so that is the correct answer for the second part there, which gives us 2 marks. So already we have 5 marks, which is great. More marks, the better. Now we need to verify that that x has a stationary point when t is equal to 3, and determine whether the stationary point is a maximum or a minimum value. So, stationary point. Remember, that's where the derivative is equal to 0. So when t is equal to 3, does the derivative equal 0? I'm going to keep this stuff up there right now. Actually, what I can do, I'm going to move this there just so that I know, because I'm going to save this for later. Okay, so for the second part here, part B, we need to verify stationary point, blah, blah, blah. That's where the derivative is equal to 0. So we're going to plug in 3 for t, and hopefully that's going to be equal to 0. Nice little order of operations question there. 3 cubed is 27, so 2 times 27 is 54, minus 120 plus 66. 66 plus 54, the 10s give me a value of 110, plus the other 10 is 120. And that, in fact, does equal 0. So we need to actually state that this is a stationary point. It's always better to write more than less on these exams. And now we need to actually determine whether this is a maximum or a minimum. Well, what we're going to do is we're going to use the second derivative for that. So with the second derivative, so I'll write this over here. When the second derivative for when t is equal to 3, if it's greater than 0, it's going to be a minimum. If it's less than 0, it's going to be a maximum. So 3 squared is 9. 9 times 6 is 54. 54 minus 40. Obviously 14, but we don't really care what it is because it is positive. So that means that that's an x up there. That means that this second derivative here is greater than 0. which gives us a minimum value. And that's really all we need to write for that to get 4 marks for that question. Fantastic. And next up for part C, we need to find the rate of change of x with respect to t when t is equal to 1. So I'm going to get rid of all this stuff for part B, just so we can look at part C, and I have some room to play around with that. Rate of change of x with respect to t. If you write it out when you say it, you can easily see that that's dx dt. That's exactly what we had. So now we just have to plug in when it's equal to 1. So 1 cubed is 1, so 2 times 1 is 2, minus 40 plus 66. The 2 plus 66 is going to be 68. 68 minus 40 is going to give us 28. And next, determine whether the distance of the car from the point O is increasing or decreasing at the instant when t is equal to 2. So, distance. So again, we're going to have that rate of change there. Well, so the distance here actually, let me get rid of all this. All right, so if the distance is measured by this, is it increasing or is it decreasing? Basically, how is it changing? It's just another fancy way of saying, what is the derivative? So we plug this back in to the derivative. 2 cubed is 8. 2 times 8 is 16. Minus 80 plus 66. 66 plus 16 is going to give me 82. Minus 80. That is equal to 2. This is positive. The rate of change, the derivative, is positive. So when that rate of change is positive, it's increasing. So we're just going to say increasing when t is equal to 2. That refers back to part D, and that gives us full marks for all of these questions. With this one, I honestly don't feel there was anything overly complicated with the mathematics. It was really just the wording. First off, we're used to dy dx. Here they have dx dt. Did that confuse you? Because if it did, then you're just not familiar with the notation and how to say it. So if you say it as I say it, if you really think about it conceptually, you should be fine with it. And then again, down here, the distance, is it increasing? We don't plug it back into this original distance formula. It's seeing if the distance is increasing, if it's decreasing. How is it changing is basically how they're asking it. This dx dt, the rate of change, is the derivative, so plug in t is equal to 2 for the derivative. Make sure you understand the wording, and you'll get the questions. So again, if you have any questions, drop a comment.